So today, we're going to pull on one tiny little thread in the world of artificial intelligence. And by doing that, we're going to unravel one of the biggest, messiest, most fundamental problems in AI today. Okay, let's just dive right in. It's time for AI's Great Untangling.
I know. It sounds like a totally silly debate you'd have over lunch, right? But this one simple question, it actually gets right to the heart of a massive, massive problem in AI. It's really the key to understanding if an AI is just mimicking us or if it can actually truly understand the world.
See, for an AI, how it even tries to answer this question reveals a deep, fundamental weakness in the way it tries to organize our reality. It gives us a really fascinating peek under the hood, into its brain, so to speak.
Okay, so here's something you've got to understand. AI doesn't think in words like you and I do. Nope. Instead, it builds this incredible multidimensional map of reality. It literally creates axes for concepts like liquidness, or, you guessed it, sandwichness, and then it plots everything on that map. So a hot dog, it gets coordinates way, way up high on the sandwich scale, while something like, say, borscht is way over on the liquid axis.
It's a strange way of doing things, for sure, but it's logical. It's an attempt to make sense of everything. But here's the catch. This entire method of mapping the world, it creates a massive hidden problem. It's a fundamental flaw in the architecture that we are about to untangle right now.
And this core flaw, well, it has a name. It's called superposition. And it's the source of this great big tangle that we really need to unravel.
So what on earth is superposition? Well, think about it like this. Imagine trying to jam an infinite number of ideas into a tiny, finite box. That's basically what current AI does. You just can't organize infinite information in a finite space without it becoming a complete and utter mess. It's just tangled.
And the result of all this is, frankly, kind of absurd and wildly inefficient. Because every single concept has to have a value on every single axis, the AI is forced to waste energy calculating things like the sandwichness of a Tuesday or the catness of gravity. Can you imagine? This creates an unbelievable amount of noise, making it incredibly hard for the AI to figure out what something actually is.
This whole thing, it really just boils down to the math. And I want you to look really, really closely at that squiggly equal sign on the before side. That little symbol, that's the key to everything. It means the answer the AI gives is always just an approximation. It's an educated guess. Sure, it might sound plausible, but it is never, ever guaranteed to be true.
But what if we could get rid of the guesswork? What if we could build meaning in a totally new way, from the ground up? Well, this is where the solution, the Great Untangling, begins.
The difference between the two approaches is pretty stark. You know, the old way, superposition, it's like a messy pantry where everything's just jammed in together. But the new way, it's like an infinitely expandable library where every single concept has its own unique address, clean, organized.
And this new, organized approach is called the semiotic web. It's an architecture designed from the ground up to completely eliminate that superposition problem.
So how does this new system even work? Well, it starts by replacing simple words or tokens with a brand new building block called a tokum. Now, a tokum isn't just letters on a screen. Think of it more like a smart container that holds its own semantic DNA. It knows what it is, it knows how it connects to everything else, and, this is absolutely crucial, it knows where its information originally came from.
So by using these tokens, the system moves from that dense, messy tangle to a clean, organized structure. And this allows for a monumental shift, from just guessing to actually knowing. So on the left, that's what we have now, a probabilistic system. You go from data through training and you end up with a best guess. And there's our squiggly line again. But the path on the right, that's totally new. It starts with something called tokumization, and it leads to a deterministic, grounded answer. And look, it's signified by that solid equal sign.
And here we see it in the math itself. Notice something on the after side? The squiggly line is gone. It's been replaced by a hard, solid equal sign. Y equals dm. This means perfect decoding, zero guesswork. Every single answer is built from traceable atoms of meaning, all backed by explicit, real-world evidence. Okay, let's see how this works in the real world. If we ask this new system to find all the liquids, it's surgically precise. It targets only the property of liquid. Then it scans for anything that has a direct, proven relationship to that property. And finally, it spits out a perfect, traceable list. It's that simple. There's no guesswork, no noise, and absolutely zero chance it's going to get distracted wondering about the liquidness of a toaster.
You know, this shift from guessing to knowing has huge real-world implications. This isn't just a small improvement. It's a fundamentally different way for machines to process information. We could be looking at a whole new era for AI here. So what's the payoff? First up, staggering speed. We are talking performance improvements of up to 20,000 times. That's the kind of power you unlock when an AI stops wasting all its energy calculating nonsense and just knows the answer.
And that incredible efficiency, it translates directly into mind-boggling savings. By shifting to this kind of model, the estimated annual reduction in cost and energy is over $123 billion. A number that big doesn't just improve an industry, it completely reshapes it.
And the difference in efficiency is just profound. A traditional AI has to brute force the problem, maybe scanning 1 million documents. This new system, because it understands relationships, only needs to check between 50 and 200 intersections to find a more accurate answer.
It really is the difference between blindly searching an entire library for a fact versus just walking up and asking the librarian who knows exactly where it is.
And all of this efficiency and certainty leads us to the ultimate payoff. We finally move away from the risky black box of guesswork and into a glass box of true comprehension. We get an AI with absolute transparency, full traceability, mathematical certainty, and, for the first time ever, a real foundation for genuine trust. And that simple fact, it changes the entire conversation. We are right at the beginning of a new era. The question is no longer what an AI is going to guess, but instead, what do we, as its architects, want it to truly and provably know?